Hi everyone, I want to take a look at how friction acts on a rolling object, and there's a few different situations that we're going to have to look at. So here's one of them. What happens if we have an object that has a force acting on it, yet the surface has no coefficient of friction? Okay, so you should have been able to see that over the course of it sliding on the surfaces that have no friction, right, it will not roll, even down a ramp, right? It would act just like a block because there is nothing that is going to create a torque on it to start it rotating. All right, so that's the first thing. So if this object is sliding or we're able to exert a force anywhere on that object, as long as there is no coefficient of friction, it'll just accelerate translationally. All right, and after there's no force on it, it'll just continue to slide like a block on a frictionless surface. But once that object starts to interact with a surface that has a coefficient of friction, we have to think about what is going to be happening. All right, so it's moving. It ends up hitting some surface that has friction on it. There is a velocity of the center of mass. As soon as it makes contact with that friction, right, just like any sliding object, the friction is going to oppose the tendency for it to slide, right? So then there's going to be friction acting on that. It's going to slow the center of mass speed, it's going to slow the translational speed, and then increase the rotational speed. By creating that torque at that point, it's going to start rotating due to the friction. And then at some point later, the rate of rotation will match up with the rate of translational speed, and then it'll start to roll smoothly. Once it reaches that point, we can, since there's not going to be any driving force, state that the object will then be moving at a constant speed. And once we hit that constant speed, there is no tendency to slide. Therefore, there is no friction. The object will simply move at its constant translational rate, and the equation of V equals omega r is now acting so that the rotational speed is in sync with the translational speed. Okay, so really what's happening is these particles are basically moving straight down until it hits this point P, and then it's going to lift straight up. Now, that sounds a little weird, but it's all in relative motion. So as an observer, standing right here, we would just see this particle stationary and these particles moving down, this particle moving up. And if we were to travel along with the object, that's exactly what we'd see for every particle. This point would look like it's not really moving, and these particles would just be moving up and down. All right, so we would be moving along with the same center of mass speed. As the object. And since those particles are simply moving straight up and straight down, as it's rolling, it's basically just putting the particle down and lifting it back up. There is no tendency to slide. There will be no friction on an object that is rolling smoothly and not accelerating. So we're going to take a look at this video again. play it all the way through. And we can see what sides have friction and which ones don't. Okay, looking again. There is friction over here, and you can see that as it rolls down, it looks normal. Once it goes across the green area, there is no friction there either, but the rolling appears to look normal. One more time. All right, so as it rolls across the green at first, nothing looks out of the ordinary, because it'll roll with the same, with that rate here, which looks like it's rolling smoothly. And you can see once it gets up to the top, that it's losing that energy just because it's moving upwards throughout the hill. And as it rolls backwards, you can see that the friction's not creating a torque to change it. Right? But right there's an example of it rolling smoothly. Even though there's no friction, it looks like it's rolling normal. So now what happens if there is a driving force? Now there's two types of driving force that we can look at here. If we think about the wheel that we've used for demonstrations, we used it with circular motion. This guy right here, right? And there's that handle that's right in the center there. So if we grab that handle and we pushed it along the ground, all right, so it's stationary, we start applying a force, the wheel will accelerate. So applying a force at the center of mass is just going to cause it to start to slide translationally. And if we do have a coefficient of friction here, we will get that tendency of sliding so that the friction will end up acting backwards, which will create the torque for the rotation. And as you keep applying that constant linear force, the speed will continue getting greater translationally as well as rotationally. If we were to get it up to a certain speed and then stop applying the force, it'll then roll at a constant speed and that frictional force disappears. Well, there's another type of situation we can look at as well, where instead of it being applied at the handle here, maybe we can apply the force with your hand and start the wheel turning that way. Okay. You can also think about it like a bike chain. So we have the gears here. The chain will go around a larger gear over here. You have the pedal, and you're using that pedal to drive the acceleration of the tire, right? And if we were to do that and keep it above the ground and speed it up, we would, well, and then you would lower it down and touch the surface. All right, so if we accelerate the wheel and then lower it down on the surface, think about what direction the friction is acting in that situation. What direction is the sliding occurring, right? So the wheel is pushing backwards on the table. All right, so on the table, the wheel pushes back. And on the tire itself, then the table on the wheel has to be forward because it's slowing down the rate of rotation. So there's the wheel pushing back on the table. The table and the wheel is what propels it forward. Just like walking. when you have to walk forward, you have to push backwards on the ground pushes you forwards. So there's the three situations of rolling. If it's rolling at a constant speed, there is no frictional force. If there is a translational force driving the motion, then the frictional force is what's creating the torque to cause the rotation, and it's going to be caused from the friction on the ground acting backwards, right? And if the driving force is a torque, like your hand or the bike chain, then the friction is going to act opposite the directional motion of the particles, right? So here the particle's velocity is this way. It has to exert a force backwards on the ground, and therefore the ground exerts the frictional force forward on the wheel.